So again, we're going to do the same thing. We're going to determine the degree. So the degree, so let's count the number of turning points. We have here 1, 2, 3, and 4. So the fact that we have 4 turning points, n minus 1 is equal to 4, then we will have is equal to 5. So we will have 5 as our degree. Okay, as you can see here, you can confirm it also in the equation. We have here a squared, and degree of 1. So if you add all that up, then you will get a 5. Okay, so the next part would be to determine the zero. So the zeros are -2, 0, we have 0, 0, the origin, and then we have 1, 0. So as you can see, we have here, this is for the origin, and this is for x is equal to -2, and then x is equal to 1. Okay, so that makes sense, right? Okay, and again for determining the multiplicities, so you just have to take a look at how the graph behaves. So it just touched -2, so x plus 2 has um, an even multiplicity, and also it also touched the origin. So as you can see, x squared here, so you have 2 as a multiplicity, and it crosses 1. So the factor x minus 1 here as uh, an odd multiplicity of 1, so that we will have a total degree of 5. Okay, so that's it for those graphs. So we will use these ideas later in finding the graph of in the exercise. Now we also have another um, observation when it comes to the graph. So we can determine the end behavior if we given our um, leading coefficient. Okay, so when n is odd, and our degree also, so when n is odd, so when the degree is odd and the leading coefficient is greater than 0, then your graph will behave like this. The end behavior, so we'll have as negative, as f of x approaches negative infinity, so uh, f of x approaches negative infinity as x approaches negative infinity. Okay, so and as x approaches positive infinity, f of x also approaches um, positive infinity. Okay, so let's take a look. Does this corroborate with what we've been discussing so far? So let's see here. We have an a that is greater than 0 and a n that is odd. So did we have an example here? So yeah. So as you can see right here, our a here is 1, right? Okay, a here is 1 and our n is odd. We have here our n is 3, right? And our a is greater than 0. So as you can see, the end behavior of the graph is just like that. Okay, so we confirmed it. So there are also other situations. For example, if n is odd and an is lesser than 0, so the graph behaves like this one. And when n is even and a is greater than 0, so as you can see here, um, as x approaches negative infinity, f of x increases, so it goes to positive infinity, and as it goes to positive, as x goes to positive infinity, f of x also goes to um, positive infinity. So we have another case right here. If n is even and an is lesser than 0 or negative, so we have right here so also as a different behavior. So just to give you an idea of what a is, if you are finding it's the equation given a graph, so that's a good indicator as well. Okay, so let us see the behavior of the graph given the following functions. Okay, so we have right here for the a, for the first one, we have a degree of n, right? And a degree of n and our leading coefficient is negative. So if we take a look, a degree of 3. So we have here n is odd, and then the n is odd, and then our an is lesser than 0. So does it behave like this? It should behave like this, right? So as you can see, it's definitely right. It's behaving like that. So how about in this one? We have here an n with n which is even, and then a leading coefficient which is greater than 0. So n is even, and the leading coefficient is greater than 0. So it definitely is behaving like that also. Okay? And then how about the last one? N is odd, and then we have a positive leading coefficient. So we have n is odd, and we have a positive leading coefficient, so it should behave like this. So it behaves like that. So as you can see here, we've confirmed these results. Okay, so now that we know all that, let us try to determine the graph of this particular, determine the polynomial function of this particular graph. Okay, so what do we do first? So what do we do first is we're going to determine the degree. So we find the degree. So how many turning points are there? So we have a 1, 2, and 3, right? So we have here a 1, 2, 3. So we have 3 turning points. Okay, so the fact that we have 3 turning points, that makes our degree equal to 3 plus 1, which is equal to 4. Okay, so we have our degree of 4. Okay, so what's the next thing that we need to do? So we need to find the zeros, because that will give us a good idea, an idea of what the factors are. So you have your negative 3, 0, you have your 2, 0, and 5, 0. So you can write our equation as y is equal to a multiplied by x plus 3, then x minus 2, and then x minus 5. So very cool, we are almost there. So what the next step would be to determine the multiplicities. So as you can see here, we have a total degree of 4, right? We have a total degree of 4 right here. So how do we determine the multiplicity? So again, we take a look at the graph. So we have here um, on negative 3, on the 0, negative 3. So it crosses, right? So the graph crosses our 0, negative 3. So this must be odd, right? This must have an odd multiplicity. Okay, so how about in positive 2? It just touches that particular 0. So this should be even. The multiplicity of this should be even. And then for 5, we have here it crosses again. So this should be odd, right? So given that our n is 4, and we have here odd, even, and odd, so how you determine it? How will you distribute this 4 in order to get this an even for x minus 2 and an odd for x plus 3 and x minus 5? So, of course, you x minus 2, you give 2. Then for x plus 3, we give 1 and then 1, right? This will be a total of 4. Okay? So those are our multiplicities. So we've determined our equation to be y is equal to a multiplied by x plus 3, then x minus 2, then x minus 5, so the x minus 2 squared. So now the only thing that we need to do now is to determine this stretching factor a, or also our leading coefficient. So how do we do that? So we use another point aside from the intercepts, which we have here, which is 0, negative 2, our y-intercept. So let's do just that. So we have here negative 2 is equal to a times 0 plus 3, 0 minus 2 squared, and then 0 minus 5. So negative 2 is equal to a times 3. We have here negative 2 squared, so that's 4, and then negative 5. So what we have here, a is 20, negative 20 times 3. A will then be, so this is 60, right? So, and this is negative, so positive 1 over 30. Okay, so now that we have this, our final equation will be final function, polynomial function will be y is equal to 1 over 30 x plus 3 x minus 2 squared and then x minus 5. Okay, so there you have it. Very cool, right? So we have deduced our way to this polynomial function by just taking a look at the graph, which is really cool. Okay, so thank you for watching, and I hope you learned something, and see you in the next videos.